So, hi everyone. I see lots of people here, and this is the first time when we, AutomateIT, are doing something different than before. And I see people still gathering, so that's a good thing. So, first time we're doing it live here and streaming at the same time as in Zoom. Let's start about the AutomateIT, or automate it. Both ways are correct way to say. And we started this initiative like 2 years ago in 2020, in October. It was the first time when we did the first event. It was online because of the COVID. But we always aimed for something like this, to just gather people and talk about automation things. That's the thing that we're interested in. So AutomateIT event is an event for people who believe in automation, who believe that we can do things better, who are not lazy, but who believe in process, of course, because we believe that we can improve things. And that's the most important thing to move forward. So for this time, I want to introduce our first speaker. This is Louis Prescott. He's a pretty known person. You can find him in Test Automation University. He has courses about API testing with JavaScript. And this time, Louis will talk about bidirectional testing. So, where to you, Louis?
Okay, so we're going to be talking about bidirectional contract testing today. It's something that Pactflow released earlier this year. It's really exciting because it allows you to optimize what you're doing, but I'll go on to explain a bit more about that later. So a little bit about me. As mentioned, I'm on Test Automation University. I'm also QA lead at Seracare, which is a home care startup in the UK. We work with many care companies now that we've acquired, and we are delivering technology into an industry which really hasn't had it before. Also about me, I have a podcast which I hosted some guests and we talked about contract testing. So if you want to hear more, you can listen to my voice more on my podcast. Also appeared on Smart Bear's podcast about people behind the apps, which was a good listen. And then I also have a course on Udemy as well. So before I get into what bidirectional is, I'm going to talk to you about what contract testing is to lay that kind of foundation. So I found this article which talked about contract testing being the new unit testing in a microservices world. And I'm not sure it completely replaces unit testing, but the blue line is microservices. The popularity has gone up over time, obviously. And then the red line is monoliths coming down. They seem to be meeting in the middle around about 2020, maybe. So this is the reason why contract testing has come about, because people want to find other methods in order to test their integrations when you've got many distributed systems. So if we look at what it was like when we were using monolith applications, we had API tests which would hit the application, and then say you have a API response which collates multitude of data from different domains because it all lives in the same place. And also when we're hitting the API, we're also impacting other services. So when microservices came about, and the reason why it's so popular is we can isolate those services and make those domains unique, and then we have the opportunity to test those in isolation. The benefit of this, obviously, is the isolation and the ability to deliver services independently of each other, whereas in terms of testing, it makes it much more complicated. So I've got to ask the audience now. So if you go to menti.com and enter the code, or you can scan the QR code, and there's a couple of questions. So go to answer both questions. So I want to find out what you already know. So hopefully you guys can help me along the way. and also what issues you have with your end-to-end tests. So we can identify some of the issues that hopefully contract testing will solve for you. So, I mean, hopefully lots of people have come here to learn. So nothing is a good answer for me. And we said bi-directional earlier, so maybe that's what someone's picked up on. But yeah, I think a lot of what people have heard about contract testing is that it's a thing and it solves some of the issues we have with testing microservices, but a lot of people don't know how to get started, how to sell it to their teams, how to get buy-in across the organization. So hopefully today I'll touch on some of these subjects. Consumer-driven contract testing is up there as an acronym, which is good. APIs, it also does events as well. So if you have messaging, contract testing also supports that. Cool. So hopefully you guys are going to walk away today and you will have learned something. So if we look at some of the challenges that we have with end-to-end tests, so we have long run times, they're slow, they're flaky, they rely on an environment. The responsibility, absolutely, sometimes it sits across teams. Maintenance. There's lots of things which I think apply to a lot of people, and people have had experience with a lot of these things. So contract testing doesn't solve all your problems, but hopefully it offers you another perspective on how you could potentially reduce some of this pain that you're having. So to tell you a little bit about my situation, so I joined my company about a year and a half ago that I'm currently working for, Sarah, and all of their end-to-end tests, which were written in Cypress, were all mocked. So they're not a true reflection of what's actually happening in the application, and those mocks can go out of date. So it doesn't reflect the production environment, and it basically worried me a lot that we were just running these tests and then happily pushing to an integrated environment without actually knowing whether it was going to break or not. So it can have some risks to it if we do it that way. Obviously, it improves speed of your tests and other things, so it does have benefits. So what we're trying to do at Sarah is we're trying to move to more of this kind of situation. So we write everything in TypeScript on our front end, and on our back end we use .NET. So we have all of the static kind of type, safety, and all of that kind of stuff built in. We're trying to write some unit tests which test the business logic, anything that we can isolate from a functional perspective, and then we're implementing the contract tests. We also have kind of a component layer as well, which we talked about with all the mocking that we were doing. And then we actually have quite a lot of integration tests on our back end because we are actually hitting the database in that service, but we're not doing end-to-end. So again, we've got another gap there. But what we're trying to do is plug a lot of that end-to-end gap with the contract tests. So we're trying to create this kind of structure. It's kind of based on the Spotify honeycomb model, but I've just added in contract testing into there. So a scenario where contract testing would have come in quite handy for me is I was working at an organization where we had this logic in our code. And what this logic is doing is it's stripping out all of the null values from our response. So any key value pair in our JSON response, which returns a null, we just strip it out because we're like, well, no one cares if it's a null because there's no data there. Whereas one of the consumer teams was relying on a null to impact their behavior, right? So if it was null, they would either render the front end differently or they would do something differently on their side. So they were relying on this value, but we just stripped it out So it's one of those things that we should be doing. We should be communicating with those teams. Another scenario we had is we have two versions of the API. You make changes to one side, and it affects the other side because they're both using the same root. So Martin Fowler does a better description of what it is, but basically what we're saying is that contract testing is testing at the boundary. So we're not doing the full integration. We're leaving that to our end-to-end tests and our integration tests, and contract test is just testing at the boundary. So we're making sure that each of the services is conforming with our API contract, which we all have because they're generated, or we've set them up front to build our applications. So contract testing kind of offers that isolation that we were talking about earlier with the move to microservices without having to rely on those dependencies. And the way that I like to describe it is we are flipping integration test upside down. So we're changing who owns the test scenarios. When we look at contract testing, we think the consumer actually generates the contract. So the web application or the mobile application is creating the test scenarios, and then they're giving them to the API team. Whereas the API teams that I've worked on before, we write our tests based on our code, right? So we know the behavior that we expect, so we write the tests for that. Whereas with this, what we're saying is that someone else is writing those test scenarios for us, and then the people who are using the API. So it seems like a better way to do it. So how does it work? So we have our web app, mobile app, or another API service in the left-hand side, and they create the contract. So they are actually mocking out any of the API, so they don't communicate with it. They just set it up as if they were going to interact with it based on that contract, based on that conversation they've had about how the application is going to be built in the first place. They set up the expected response. So what do they want to get back? That then generates the contract. At that point, we can then store the contract in what we call a broker. And all the API service down on the right-hand side is doing is replaying exactly what the consumer set up. So that contract that was created from the consumer is just replayed on the local instance of the API. That then sends data back to the broker, which says that I've verified that what you're doing on your side conforms with what I'm doing on my side. At no point have the two actually spoken to each other except via the contract. And then the consumer then can call the Pact broker to say, can I deploy the application? Which is what it's basically doing is closing the loop of the integration and saying, can I deploy with this version of the API? So hopefully that makes sense. But the consumer sends a HTTPS exactly like you are doing in your code. There's no code changes. We're just intercepting exactly what you're doing, creating the contract. That's stored in a broker where you may have multitude of consumers using that API service in lots of different ways, or you may have lots of interactions. So different people are interacting with it in different ways. And it can be quite hard at times to keep it all in sync. And then on the provider side, all they're doing is they're pulling it down from the broker, replaying it, and then everyone's happy. So there's some complexities which come with contract testing, which you don't have in the end-to-end testing scenarios because everything's spun up and you have an integrated environment to work with. So one of the conversations that I had on the podcast, he was building microservices and they were struggling to define what the boundaries were. So if you don't know what the boundaries are of your contracts, then it's quite hard to define what the contracts are. So that's the first step. Then setting up your data between teams can be quite challenging because the consumer needs to tell the provider what data needs to be set up before they run their tests. So that is another challenge. Versioning and environment tagging is just something which is generally difficult, but hopefully you have a kind of consistency within your team, and you can apply the same thing to Pactflow. Consistency and standards across teams. Obviously, you want to make sure that each of the consumers is using the same kind of syntax and using the same way of interacting. Otherwise, you're going to have lots of inconsistencies. And then the pipeline, as I described the steps, obviously you then need to make sure that everything is triggering correctly in your pipeline before you release. So there's some complexities to it. It's not like you can just spin it up tomorrow and it will all be okay. But this brings me on to one of the core complexities of just generally building microservices within distributed teams especially, is communication. From stories that I've heard, also experiences that I've seen, people are using Word documents to pass around API documentation, which just seems like a bad idea, right? Because then someone's got a version of a Word document that is out of date. Obviously, we've got online versions of it now, but it still relies on someone looking at it to check that there's changes. Often we put this documentation into Confluence, where you can see versions and you can update as you go along. And then lots of people use Swagger or OpenAPI to generate their API documentation once they've created the code, and then they can share that. And whenever the code changes, then you've got that live documentation. But that's still not verifying anything. So the documentation is there, and people obviously want to follow it, but it doesn't verify that they are following it. So what are some of the frequently asked questions that I get about this topic? So as we said around the challenges that we have in our end-to-end tests, in our integration environments, we want to either reduce the time that these tests take, or we want to reduce the maintenance costs, the flakiness that we have. So that's obviously contract testing provides some of that, but as you saw with the honeycomb model, is that you're not going to reduce all of them. You still have to have some that test the full integrated environment. Contract testing just checks the contracts. And you want to use contract testing, but you don't know where to start. So bi-directional, which I'm going to do the live session on, will hopefully allow you to use it on your existing code. So you don't have to start from a position of adding duplicate tests or adding more tests because you don't know how to use the framework. Hopefully you can just adopt this, and this will allow you to optimize what you already have. And then, as I mentioned, contract testing doesn't replace end-to-end testing. So some of the scenarios that you want to use within your contracts is the error codes, for example, that you expect to be returned. If that changes based on certain parameters or certain requests, then obviously you'll pick that up within your contracts. And then anything to do with like types, like I said about the null values, any kind of contract changes like that will obviously be picked up. So you can move a lot of that kind of expected outcomes that you have in your integration tests and have in your end-to-end tests, you can move them down to the contract testing level. Hopefully that will speed up your workflow a little bit. So now to introduce bidirectional. So what we were talking about before was consumer driven, right? The contracts are created by the consumer first, and then the provider can generate, then they can verify the contracts. But bidirectional allows you to do it both sides. So the benefits of doing it are you're not relying on a dedicated environment. You can safely deploy into continuous delivery. That's kind of the end goal, is you have all of these, all of your consumers set up, and then you can have confidence when you're releasing without having that reliance on an environment. visualizing. So one of the kind of core attributes of Pactflow is it allows you to visualize that view of who your consumers are, how they're using your systems. And then the verification process. So when you're using your mocks and your stubs, no one's telling you that they're the correct mocks and stubs to use, whereas in this scenario that you have that verification. So this is a diagram of kind of how bidirectional works in comparison to what we saw before. So both sides are generating a file to push up, whereas before just the contract was provided by the consumer. Now the consumer still provides the contract, but it's generated by like your existing mocks or stubs. So in the example, we're going to use Cypress to use that to intercept and generate a contract. And then on the provider side, we're going to use the Swagger documentation from the API, and they're going to push that up and say, we verified that the Swagger documentation works. And then what Pactflow does is it compares the two. So it's going to compare the contract against the verification of the API Swagger documentation, and it's going to say whether the contract has been adhered to on both sides. So now you can use your existing tests. Say you have lots of tests already set up, like we do in my situation. We've got lots of Cypress tests with lots of mocks, so we can generate contracts off the back of those. And then we're going to use this tool, Schemathesis, which allows us just to point it at the Swagger documentation, and that's going to do the testing for us based on whatever the documentation says. So I don't have to set up any code on that side either. So there's other adapters out there, not just the two that I just named. So we've got the consumer ones using Mock Service Worker, WireMock, Cypress and Playwright. And then on the provider side, you can use tools of your choice as well. Ready API, so SoapUI, Dread, Postman, or Schemathesis, as I'm going to show today. So there's adapters being added all the time as well. Playwright was just released recently. Cool. So we're going to do a little live session now. Hopefully everything goes to plan. So what we're going to do is we're going to show how I'm going to publish the API side first without any contracts that exist. And then we're going to create a contract in Cypress, and we're going to push that up, and we're going to check whether it was verified or not. So this is the app that we're going to be testing against. So it's based on a show that we have in the UK called Bake Off. I don't know whether you have seen it or have a similar version, but Paul Hollywood wants an app which shows the ingredients of the cake. So it's very simple. It just shows the ingredients. Currently, I don't have the API running, so I can't show the ingredients because that's what the stub's going to do. And then I have the API, which I'm going to run the Swagger documentation against. The first thing we're going to do is we're going to use this CLI tool within Docker. So Docker provides us the wrapper around Pac's CLI. So we're going to publish the Swagger doc to not this one, sorry. We're going to publish the Swagger documentation to Pactflow. Before we do that, we're going to run Schemathesis against it. So it's going to run the checks against the URL. So I actually deployed this to render, which just allows us to deploy a Node.js server to the application. So this is hosting our Swagger docs. So we're going to pull down the Swagger documentation from there. We're going to store it locally. Then we're going to run Schemathesis against it, which is going to use that Swagger documentation to run the checks against that local API that I just showed. And then we're going to publish that to the Pack broker. So I didn't load up the pack broker earlier, just to show you that it doesn't exist and I'm not making stuff up. So this is the default one that gets created when you launch Pactflow for the first time. So there's no bake-off API in here. So I'm just going to run the publish command for the server, which is going to run that shell script. So it's pulling down. It's going to take a little while to spin up the server, so I might have to run it a couple of times. But yeah, so this is using Swagger docs that already exist, right? So if you have an API that's already running, you can then point it to that and pull that Swagger documentation down. And then you spin up your local API service so you can run the checks against it, and then you publish it. I haven't built any logic into my API, so sometimes Schemathesis gets me because it's running a check that I haven't coded into my application, but it's passed this time, so that was good. So I didn't provide details that I needed to provide. So I need to add in the token for my Pactflow instance, and also I need to add in the version of my API. So we're going to run this again. Cool. So we successfully published the contract from the provider side. Well, the verification of the contract, which doesn't currently exist. So you can see here now we don't have the consumer side. So we're going to create that now. But we have the ingredients API. If we have a look, we can see the Swagger documentation in here, and we can see the verification. So the verification produced unreliable results, apparently. Cool. So now we need to set up Pact. So the Pact adapter that we have for Cypress, I've already added the plugin. So in the Cypress config, we have the Pact Cypress plugin, which obviously launches the plugin for Cypress. And then we have the import into the end-to-end command section. So this will allow us to have the Cy commands within our test. So I'm going to do a Pact setup. Why that's not auto-completing. Cool. And so we need to name our consumer. So this is just a string value, but ultimately this needs to be consistent with whatever the consumer is calling their application, usually whatever's stored in your source control. And then obviously the provider needs to match with what we've set up in Pactflow and what the provider said it was called, so we can do the matching. And so this is where the magic happens. So Cypress has this command, cy.intercept, which will point to our API, which isn't running. And all I need to do is provide the URL of the API to get the response. So this will then return us. We want it to return a stub, so that when we run the test, we can return the stub response rather than throwing an error. We want it to return a happy response, so we want it to be a 200. And then this is where we're going to set up the body of our response as well. I've added a callback when it doesn't require a callback. Live coding. Cool. So, and then we have these headers which are just within the application itself. So I'm just going to copy this because I don't remember what it is. Cool. So where we left off, we were creating our Cypress response, and we intercepted it here, and we added the wait to return the response and check the response code. So if I've done this correctly, then we should be able to launch Cypress, run the test, and it should generate us a contract. So pact setup is not a function apparently. It's because it's called setup pact. And the ingredients was never returned. No request ever occurred because I set up the thing so we can watch it again. So we click the ingredients, and now it's returning us a response which we set up in the intercept command. And you can see now we've got this write file. So that has generated us a contract. So we can see in the Cypress folder now we have this JSON file. So the JSON file is our contract. So it contains the packed information that it needs, and all this is converting that intercept commands that we created and setting that into an interaction, which is what it's going to use to verify that the Swagger documentation conforms with the other. So I have this other publish file, which again uses the pact CLI, but this time it's going to publish the pact contract that we just generated. So again, I need to supply the version, and I need to provide the token. So the contract has been uploaded to Pactflow. I refresh. So now we have the consumer side of the contract, and we have what we uploaded earlier, and we have this success here. So what it's done is it's compared the Schemathesis results, and it's compared the contract that Cypress has created, and they both match. So we're happy that we can now release the consumer with the current API version. So that's that. Few hiccups along the way, but we made it. Cool. So obviously, if you have any questions after today, you can obviously pull down the GitHub repo, so you can play along at home, and connect with me on LinkedIn or Twitter if it still exists in a few months' time. And I also have a website, pacman.co.uk, where you can reach out to me on there as well. And Pactflow's slogan is safe to deploy on Fridays, which I'm not sure I do endorse, but it's definitely something to aspire to. So thank you very much.
First of all, thank you for the helping us to understand what the contract-based testing and bidirectional one means. I've got a question about the verifications being performed. So we saw the total number of those applied and then number of passed. So maybe a little bit details around them. What kind of verification?
Yeah. So when you implement traditional contract testing, where you have the contract and the then you just replay that contract's scenarios. So it's doing those interactions. So within that contract that we created, it had those interactions. And so that is what it's comparing. So it's comparing that interaction with the verification that we did on the Swagger documentation, which is exactly the same. Swagger documentation just has a value, which is a parameter of the cake name, and it's saying, I expected it to return this list of ingredients. So it's doing all the interactions. So if you, in your Swagger documentation, if you have a 400 response, it will also do that one, right? And then on the consumer side, you would need to say, okay, if a 400 happens, this is what I expect. And then it will also do that interaction. So you can set up as many interactions as you want against the API service, and then it will just verify those two things. But if it fails, it will be because the Swagger documentation says something different to the consumer. And yeah, if I had had more time, it would have been nice to see a failure as well, because that's exactly what we're trying to solve.